My name is Eric Roof. I'm Applications Manager for Bruker Nano. And what I have here is the Multimode 8 Atomic Force Microscope. This is the benchmark for high-resolution imaging in the AFM industry. And we've brought it here to PicCon to show off some of the new capabilities with scan assist and peak force tapping. An atomic force microscope, as you may know, is an imaging tool which will give a three-dimensional map of the sample surface with very high spatial resolution. With this instrument, when we zoom out all the way, we're looking at a field of view that's about 125 microns by 125 microns, and we can zoom into the atomic scale. Now, what is new with this instrument is some proprietary scanning technology which is enabled by the controller electronics. It's an imaging mode that we call peak force tapping. You may be familiar with traditional imaging modes: contact mode, where we push the tip into the surface, causing the cantilever to bend, and tapping mode, where we oscillate the cantilever at its resonance frequency. With peak force tapping, we are oscillating the cantilever below its resonant frequency, in the neighborhood of 2 to 8 kilohertz. And what this enables us to do is that every tip-sample interaction creates a force curve. If you come over here, you can actually see a plot showing force versus time. And so we can see the cantilever, the tip snap to the surface. We can see the cantilever deflecting upwards and pulling away and snapping free of the sample surface. This plot can be recast into a traditional force curve, and we can see that we can control directly the maximum force that is exerted during the imaging. It's the control of that imaging force that's the key to peak force tapping technology. One great feature that's enabled by peak force tapping is an imaging mode called scan assist, which is an algorithm which will optimize the feedback parameters for you. So what this means is that if you're used to operating in AFM, you know that you need to constantly monitor and adjust your scan rates, your set point, and your gains. The scan assist algorithm will optimize all of those parameters for you. And so this means you don't have to be an expert to get good quality AFM images. Another capability that's enabled by peak force tapping is quantitative nanomechanical measurements. And what we do with this is we do further analysis to the force curve. If we look at the unloading portion of the curve here, we can extract modulus if we know the cantilever stiffness and we know the end radius of the tip. This will give us a quantitative modulus. We can get adhesion as a separate data channel. And a final piece of imaging technology that's enabled by peak force tapping is something that we call scan assist HR. We're imaging in standard scan assist mode right now, and we're scanning at a rate of about 1 hertz. That's a fairly typical imaging rate for AFM. With scan assist HR, we have a high resonance frequency piezo which is going to drive the cantilever, and this will enable us to image at nominally 6 times faster than standard imaging rates, while maintaining equivalent image quality. So you can see we're scanning now 6 times faster. We're getting the equivalent image quality. We can scan about 20 times faster to get a survey scan, so we can find a large region of interest and zoom in on it.